Hello guys, welcome back to another video, and today I'm going to be showing you how to solve series RC circuits. And our final goal for this is to find the power triangle of said circuit. Now to do that, we're going to start at the very beginning and get the Z, also known as a total impedance, also known as the total resistive or opposition to the circuit. So we have a resistor 1, capacitor 1, and capacitor 2 all in series with each other. Now to find Z, first we're going to need the total reactance and the total resistance in the circuit. Now we do only have one resistor, so the R total is 91 ohms. Now to find XC of capacitor 1, which is again the reactance of this capacitor, we're going to need to do 2 pi. There's going to be 2 pi times the frequency of the circuit, which is 1.2 kHz, times the capacity of this capacitor, which is 0.22 microfarads. Can't forget about this part because I have sometimes 2. To the power of -1, also known as the inverse of this equation, which after you punch that into the calculator, you should get 602.9 ohms. Now to find XC of 2, it's going to be 2 pi times 1.2 kHz times the capacity of this capacitor, which is 0.76 microfarads to the power of -1, which when you punch that into your calculator should be 174.5 ohms. Since these capacitors are in series with each other, we don't have to do, any kind of special formula. You literally just add them up together and you should get 777.4 ohms. Now to find the total impedance of this entire circuit, you have to do the square root. You have to do the square root of XC total to the power of 2 squared plus resistance total squared. So in other words, that means that should be the square root of 777.4 ohms to the squared plus 91 ohms squared. Which after doing all that math, the total impedance should be 782.7 ohms. Now that's the first step of the whole shebang that we're going to do. Now I think we should go ahead and get the phase angle out the way, which is going, if y'all don't know, the power triangle it's literally just trigonometry. So to find that, it's going to be tan in reverse of x of c divided by r, which when you punch that into your calculator, it should be 83.3 degrees. The next step that we're going to need is the total current of the circuit, which is a very simple equation. It's literally just the voltage divided by the total impedance, which is 10 V RMS divided by, and after you do that, it should be 12.7 milliamps. So now we're coming down to the wire, where we need to find pretty much all the powers that we need. Now to find the true power, we're going to need to do the total current squared times resistance, which is 12.7 MA squared times 91 ohms, which should equal 14.7 milliwatts. To find the reactive power, we need to do the total current squared times X of C, which is 12.7 MA squared times 777.4 ohms, which should give you 125.4 mVar, which is the symbol for reactive power. And to find the apparent power is total current squared times the total impedance, which is 12.7 MA squared times 782.7 ohms, which should give you 126.2 MVA. And that right there is pretty much all the information we're going to need, besides one little thing that we're going to do in a bit, to find the power triangle. Now basically, what the power triangle is, it's down here we have the reactive power, over here we have the resistive power, And the total power right here is literally just parabolum theorem. I still don't know how to say it, and I am now a freshman in college. So all we do, we put the reactive power down here, which is 5.4 mvar, and the true power right here, which is 14.7 milliwatts, and the total power right here, also known as the apparent power, which is 12.2 MVA. And then this angle right here is what we saw for earlier, which is 83.3 degrees. And the last thing we're going to solve for is this angle right here, which is the power factor, which is literally just cos of the phase angle. And after you do that math, it should be 0.12 degrees. So this angle right here is 0.12 degrees. And guys, we did it. We found the power triangle of this circuit right here. I hope y'all enjoyed this little mini lesson. I might do this more on, more lessons I have in the future. But I hope you guys enjoyed, and I'll see you guys next time. Goodbye.